Hello everyone, my name is Ashish Malviya and my student ID is 224211616. This is a midterm assignment for SIG718 real world analysis. So this is the presentation content. We start with the data visualizations. We'll then move to a transformation of the data. Then we will build the model fitting and do evaluation. And after we will do the predict the why and do a justification of that. So let's start with the data visualization and try to understand the data set. So currently we have a data set with the total number of rows 671 in which we need to use a 340. This data is for the energy appliances and this we need to build a model to use the energy appliances especially for the low energy houses. We can see the sample data sets available here. Total we have the 5 variables and one is a predictor. We can say the applied appliances energy use we need to predict the x1, x2, x3 and x4. Here for the input variables start with the temperature, humidity, inside and outside, and we also have visibility. Let us start to understand each variable. The first variable, the temperature in the kitchen, is we can say there is the positive linear relations with the target variables, and we can say the kitchen temperature increase so that the energy appliances is used, and this we can say the normalized data set. Go for the x2 humidity is also seems to be normalized, but we can see that there is no evidence of the strong correlations with the y. Let's understand the third variable is temperature outside, and again this is also having a very strong correlation with linear correlation with the y, similar like the x1. So we can also say that the outside temperature is good to predict the energy use for the appliances. So the data we can say that is a fairly symmetrical, we can say the normalized data set. Moving forward, the humidity again this is not a very strong correlation, is not a linear strong correlation, and the individual data set of humidity x4 it seems it's not a fairly symmetric and normalized data set. Moving toward the final variables and visibility, we can say that it is having a positive linear relation with the y, although the scatter is the spread across the span, and we can say that it's also have a very weak correlation with the x3 and the x1, and but this data set also is moderately right skewed. So I think we need to do normalizations for this data set. Same like we have our predictor value of y, which is showing the right skew, positive skewness distribution in the data set, and the skewness is 1.8. So I think we need to do a further investigation on these for both the data set before building a model. Before going to investigate data, or you can say transform the data or building a model, we need to understand if there are outlier in the data set. So you can see here clearly before and after pictures we have the outliers in the almost like all variables, and this may cause the model to predict the wrong value. So we are going to do a sum outlier treatment. Basically I'm doing here for the transform all the data or treat the data with the median values. Based on all the visualization and understanding data, and based on the k-test result, we have the p-value, variable skewness, and we also have a correlation. So we can say that x2 and x4 have the weakest relations with the y, and the x3 and x5 have the strongest correlation with the y. We are not considering x4, and we can say that there is the potential of the multicollinearity concern based on the correlation of the data set. So after doing all the EDA part and understanding data and visualization part, we have to understand, do we need to do a transform the data set. So based on the p-value, skewness, and the normalizations of data, we can understand the x5 and y, basically they have the p-value less than 0.05. so we are considering these data set is not normal, and we need to do some kind of transformation in these data sets. And we can also set that the skewness is 0.84 and 1.80, especially for the x5 and y, and both are the moderate positive skewness values. So that's why we need to do some kind of transformation. We'll see in the next slide. So after the transformation of the data set, so here are the results. We can see all the histogram have the normalized data set, and we also have the sample of the data set available here. So here is the output of the model fitting and what we have done the evaluations. So we have built the 5 model based on the request. We have the WAP, WPF with the 0.5, WPF with the P2. We have OWA and we have a CI. These 5 model we have built. We can see the evolution methods. So we have RMSE, we have average absolute error, Bayesian correlation and Spearman correlations, and we also have a weightage. So based on all the model, we can see here that the RMSE is the lowest, but we also have the correlation is the strongest side. So this is one of the strongest reason why we are selecting WA2 with p-value of the 2. So here is our clear justification why we are selecting the WPA with a p-value of 2. We can see that we have the lowest RMSE across the other model, but we can say the error is balanced across the model, and we can say that this is a balance of the accuracy. But we also have the Pearson and the Spearman coefficient here, which is the highest amongst all the model. So this is the core reason why we are selecting WPA with p-value of 2. But we also want to understand the weightage. So we can see in the data set across the model we have W with the 4, which is having a highest value across the model, which we can say that it can be of one of the factor for the low energy house predictions. After the building the model, now we have to predict and justify the predicted value. Considering the best fit model, we have a WPA with a p-value of 2, and the given axis here, we can see that we have a 4x values with the x1 equals to 22, x2 equals to 38, x3 is 4, and x5 is 34. So before doing a prediction of the y, we have to transform these data set. So these are the transform value, but we can see easily the x5 is very low, and we can see the extremely low for the transform value for the visibility x5. However, we can see in the visualization part, it was a very strong correlation with y, but here is opposite, and it is a very insignificant to a y. We can also see that the after transformation, the predicted value comes around 0.567, and when we do a reverse transformation to get the original value of the y is coming the 0.89 watt hours, which is again very insignificant. So we can say that the value what we have given, either this is not correlating with the output of y, or we need to further investigate this model to understand why we are getting a very low VAR as compared to the given value if y equals to 100. In summary, I can say that for the predicted value of y, using a PM model, we are getting a 0.567 value, and the measured value of y is 100, and this is a very insignificant, and we can see that the predicted and the measured value indicate that the model predicted does not align with the requirement, or maybe we need to further investigate to understand this model or go for the another model, and need to adjust the model parameter to fit and get the correct value for the y. So this is all from my side. Thank you very much.